Oh, it's done. Anna from
Hello and welcome to the Ecologic Institute Arctic Summer College. Sorry for the lapses there. Too much to say in too little time. My name is Max Grünig. I'm very glad to present today's Arctic Summer College. We have a very great lineup of speakers, and above all, first, I'm very excited to have here John Crump, senior science writer at Grid Arendal in Norway, and he's joining us from Arendal in Norway. Just a very brief summary of his very impressive biography. He's been a manager of government relations for the Nunavut Planning Commission, executive director of the Canadian Arctic Resources Committee, and executive secretary of the Indigenous Peoples Secretariat in Copenhagen. As a senior science writer at Grid Arendal, he works with colleagues to develop innovative ways to communicate new knowledge to policymakers and the general public. And he's also a member of the Polar Team, which provides strategic advice and information to UN Environment on the rapid changes taking place at the poles and the implications this has for the rest of the planet. And this is exactly also the topic of your presentation here today, Fingerprints of the Anthropocene Marine Litter in the Arctic. Very exciting topic. I mean, not in a positive way. Of course, it's a very sad topic. And it's actually a very interesting topic because it links everybody to the Arctic. So it's a very exciting topic because a lot of the participants here are, of course, not in the Arctic when they watch this, but this links us to the Arctic region. And I want to thank you for joining us here today. You can certainly contribute a lot of knowledge from your expertise and your experience. And I am looking forward to both hearing what you will present, but then also to the discussion later on. I want to say that if you join us today as a participant for the very first time, just a reminder, you're muted by default, but you can raise your hand and ask questions, and we will then give you the opportunity to ask your questions in person later. We will have a little bit time of discussion in this first round, and then in the second hour of our session, we have a little bit more time for the participant presentations of the first topical group on the environmental change in the Arctic, and then also discussions on these presentations as well. I'll be quiet now and hand over to John Crump, and thank you very much again for taking the time and presenting to us today from Norway. Thank you.
Thanks, Max, and hello, everybody. Thanks for inviting me to do this. I should just double check. You want me to leave? Do you want me to leave my camera on while I do this? Because I can see my face here. Maybe I can just shrink it or something.
Yes.
This end.
Well, it's perfectly fine. It's a you know, we will see mostly your presentation and then a smaller version of your face. So this actually helps us to relate. It's a great feature. If you're fine with it, we're happy to have your face.
Okay, I just figured out how to make my face smaller. You know, it's like, it's the world of selfies, right? I'll have to stop looking at the screen. Thanks, everybody. As Max said, I work out of a small town in Norway, and it's summer holiday time in Norway. July is the month that everybody takes off. Because I'm a Canadian and going back to Canada in August, that, you know, I'm still working. But if there's any sort of background sound that sounds like boats going by in a channel and people with loud music playing, that's because there is. We live on a little channel between an island and the mainland. So, but if you can put up with that, I don't even hear it anymore. Plastic in the Arctic is, well, maybe I should start with us, Grid Arendal. The organization I work for is a Norwegian foundation, and it was founded right after the Brundtland Report came out in 1989. At that time, all of the countries of the world were requested by the UN to provide some kind of support for the idea of sustainable development. And so UN Environment, UNEP, set up a number of grid centers around the world. They were supposed to handle data environmental data and be sort of processing centers for UN environment. We've all evolved over the years. Some of us have disappeared. Some of them have disappeared. Our organization has become more focused or completely focused on taking scientific knowledge and data and turning it into information that's useful for decision makers of different kinds, whether that be politicians and policymakers or business or the general public. So it's a fairly wide remit. And we work in, I forget what the exact count of countries is around the world, but the polar region is just one aspect of our work. I've been with the organization for a number of years. As Max said, I began working in with the polar team. I'm still a member of that team, but I'm also involved in helping to coordinate organizational communications. I've been thinking about the title of this thing because I've been thinking about the Anthropocene a lot, the idea that human beings, human society is actually making a signature in the geological record of the planet. There's a lot of scientific debate about exactly, you know, are we in the Anthropocene? Did it start with the Industrial Revolution? Did it maybe start with the advent of agriculture? It's an interesting discussion, and it's one that we've never had before. That human beings have never been able to put their fingerprints into the geological record in the way that we are now. 50, 60,000 years from now, several million years from now, there will be a layer of plastic in the geological record, and it will be found everywhere on the planet because it is everywhere on the planet. So I'm using plastic and marine litter as kind of a metaphor, I guess, for the kinds of changes that we're creating on the planet. And all of this is part of what's known as the Great Acceleration. If you look at this chart, and there's a whole, under the International Geosphere and Biosphere program, there were a number of indicators that they looked at, and they're all here. And the obvious similarity is that this looks a lot like the greenhouse gas emission hockey stick graph that we're all very familiar with. For most of our history, we had a minimal or negligible impact on the environment. We've always altered the environment, but it was not on a scale that really was making a huge difference. But as you can see in the last century, and even more recently, actually within my lifetime, all of the lines have started heading towards the sky. So it's in this context that we talk about plastic. And I'm trying to make myself go away here. This quote comes from Erik Solheim, who is the former Minister of the Environment for Norway, who is now the head of the UN Environment Program. And the link he makes between tropical regions and the North Pole, you can also find plastic at the South Pole, and the food chain is, I think, this is the key point. So we need a definition, and this is the one that UN Environment has used in a number of reports. We've produced a number of reports with UN Environment on marine litter. It seems like an obvious definition, but for any scientific process, we need definitions. Plastic, I think, marine litter is also, in the Arctic context, a transboundary pollutant. You may be familiar with the impact of short-lived climate pollutants in the Arctic, which travel into the Arctic on air currents. Similar things happen with persistent organic pollutants, and there's been a lot of research in these areas in the Arctic about the impact, both regional and global, on these substances. There is a treaty now for the last 15 years that used an enormous amount of Arctic data to show the impact of POPs in the Arctic environment, and the effect of bioaccumulation in the food chain and its potential health impacts on humans. Similar Similar concerns have been raised about black carbon, short-lived climate pollutants, and now similar concerns are being raised about plastic. We just, we don't know enough about the long-term impact of plastic on our bodies and on our health, and that's one of the areas of needed research. Because they're transboundary pollutants, because it's a transboundary pollutant, marine litter is going to require a global solution. There are things that we can do as individuals, and I'll get to some of that later. But this is a global problem, and it's been picked up by the Arctic Council, obviously, in its last declaration, and I'll come to that point as well. Just a few facts. Global levels of plastic production have skyrocketed. This, having seen the Great Acceleration graph, you can see what's happening here as well. In 1950, there were about 1.5 million tons of plastic produced per year. There were about 2.5 billion people on the planet using that much plastic. So that's 70, let's say, just under 70 years ago. Today, there are close to 8 billion people on the planet, and we are using 300 million tons annually. By the year 2050, it's expected that there will be another 33 billion, based on current trends, there'll be another 33 billion tons of plastic in the environment. This is an enormous amount of material created by human ingenuity and chemistry and know-how, of course. It's brought us all sorts of benefits. Look around where you're sitting. Is there anything that you're using that doesn't have plastic in it? I live in Norway, which has this great reputation for being a very green country. You go to the grocery store here, and you can buy lovely lovely red peppers individually wrapped in plastic. I was in Spain last year, and I was given for breakfast an orange, originally completely encased in plastic wrap, and I thought, oranges have their own wrapping. Why is it? Anyway? So we've just come to sense that we can use this for everything and anything, and slices of cheese separated by single-use plastic, and the main issue is single-use plastic, that you use it once and you throw it away, and when you throw it away, it goes into the environment, and some of it winds up in the ocean. And so the levels of waste are increasing around the world. And this is also a product of the process of globalization. As countries move into, as economies change and the world globalizes, China, India, Malaysia, certainly East Asian countries, the size of the middle classes in those countries is increasing. The amount of consumption is increasing, whether it's everything from foodstuffs to plastic. So the levels of production and consumption are increasing everywhere, and it's all driven by the idea that we think these things are normal and we need them and we can't live without them, so let's have more of them. What we do with the waste, of course, is another question. And so these graphics that I'm showing you come from a report that we produced. This is where I guess I can hold up the prop, if you can see this. Marine litter vital graphics. We produced a series of reports focused on the sort of graphic representation of data. This we produced alongside some other material that was being produced by UN Environment. So all of the graphics I'm showing you come from there. The issue of waste reduction, you've probably been following the news. China has banned the importation of plastic waste. Countries are banning plastic straws, plastic bags. Kenya, in the last year, I was just talking to a colleague today who's just come back from Kenya, where they were shooting some video at Kibari, which is a very large informal community outside of Nairobi, of 1 or 2 million people, with inadequate sewage and water treatment and waste disposal. And every year, the local river floods, and it's full of plastic, and it just inundates the community, floods the school, and the plastic is mixed with all sorts of other waste materials, as you can imagine. Last year, Kenya banned the plastic bag, and my colleague reported that this year, there's to the eye, there's much less plastic material floating around. Now, Kenya is pretty draconian about it because they charge people major fines, and people actually go to jail for using plastic bags for breaking the law there. So it's not necessarily a solution that every country is going to follow, but it seems to be reasonably effective there. The other issue with plastic is that it lasts, basically some of it will last forever. And here you can see, you know, what's the stretch of a human lifespan. Some plastic will be around for millennia. There's a great book that came out about 10 years ago called The Earth After Us. And the scenario is that the human race dies off because of a disease, and it's about the sort of disintegration of what we've built, our society. It's a really cheerful before bed read, but it's excellent because it's one of its conclusions is there are two things that will survive forever. One is kind of hopeful. The other is radio waves that we're emitting into space will continue, you know, long beyond the life of this planet. But for the life of this planet, going back to the Anthropocene, there will be a layer of plastic everywhere that will be red. That will be our signature. And how much is out there? This is an area of considerable debate because while there's a lot of research going on, there are no the hard numbers are hard. I mean, there's a certain amount that comes off the land. There's another amount that's lost at sea, and quantity is also defined by when plastic breaks down. So some pieces are huge, you know, parts of discarded ships or massive rigs of nets and buoys and things like that floating loose on the ocean. You know, we've all heard about the Great Gyre in the Pacific that's supposed to be a solid island of waste. In fact, that's not true, but there's plastic waste floating throughout the water column there at different depths. So it also sinks over time as well. So some goes to the bottom, some stays in the middle. So you know, measuring the amount that's out there is very difficult to do. So having said that, the UN Environment has this estimate that there's 51 trillion bits of microplastic in the sea. And so microplastic is defined as a bit of plastic that is smaller than 5 millimeters. And how they got the number of, I'll spare you how they got the number of 51 trillion, but the point is that our entire ocean system is becoming like a plastic soup in some ways. And as this detailed graphic indicates, we're starting to worry about what happens when these substances work their way into the food chain, and then the food chain works its way into us. You know, as you know, the food chain is food web is a complex process. There are a number of studies that have shown various fish species, birds, mammals have ingested plastic. And we were talking about a story here last year. We actually did a story here at our organization about a whale that was euthanized off the coast of Norway on the west coast because it was behaving erratically, and it was sick, and they couldn't get it out of the harbor. They kept coming back in, so eventually they were shot. They took it ashore and they opened it up, and they found massive amounts of plastic in its stomach, and the idea was that it couldn't eat. It was starving to death because of all of this material that was stuck in its digestive system. So it was a pretty dramatic story. It was actually one of the most read pieces on our website for quite a long time, because people can connect with whales. They're you know, like polar bears, they're charismatic megafauna. We have a harder time connecting with zooplankton and phytoplankton, which are also ingesting microscopic pieces of plastic. So we just don't know enough at this point about what is the long-term effect on the entire food web. And this is an important issue in the Arctic because the entire food web, of course, rests on microscopic animals and plants that are already under stress by increasing acidification in the ocean and those kinds of things, temperature change through climate change. So when we talk about plastic and the impact of plastic on our environment and on the ecosystems, we have to think of it as an additional stressor. And so it's just one of a number of impacts that humans are wreaking on the environment. There have been some studies that show how many species have ingested plastic of various kinds and what happens to them when they do. The other issue, of course, is that plastic debris entangles, strangles animals of all kinds, whether they're fish or birds. Again, if you search the internet, you'll find pictures of pinnipeds of seals with plastic bands around them, birds with beer can holders stuck around them. The theory about the whale eating all the plastic was that this was a deep diving whale, and the plastic floating 1,000 meters below the water surface looks a lot like a squid, and so the prey species become substituted by plastic, and it's difficult when there's no light down below, the theory goes, to be able to tell what exactly is going on. And plastic travels around, doesn't stay in one place. That's an obvious point as well. But you can see from this illustration of currents that there are a couple things to look at. One is there is this North Pacific gyre, which is where a lot of plastic is concentrated. If you look also in the North Atlantic, but if you look at the polar regions, they look relatively clean. A little bit off of the north coast of Siberia, up in the Barents Sea off of Norway on my left, and a bit in the strait between around the Denmark Sea off the coast of Greenland and Iceland. But a lot of that blank is because there's no data. There's been very little research done, and so the research effort is moving into the Arctic. And there have been news stories, of course, about plastic being found in what was considered to be a pristine environment. I've always had trouble with the concept of pristine because it implies, no humans live there, nobody's ever touched it. The thing to remember about the Arctic when we're talking about it is it's the homeland of, many indigenous cultures, and 4 million people live there. So it's not like it's a region that's far away and never been touched by human beings. It's increasingly part of the planet. Its resources are increasingly part of the resource acquisition thinking of industry or government. So it's not out of reach. In ocean currents, the plastic floats in on the surface, and then the water does a deep dive and it drops the plastic off in the Arctic. So it basically makes a one-way trip. And I told Max that I wasn't going to show video, but I thought I would just try it if you bear with me, because where are we? No, maybe we're not going to find it again. I've pooched myself, as they say. Don't you love it when presenters do this? I think, I had it all lined up, and
well, John, is it linked in your PowerPoint? Oh yeah, there we go.
There it is. We're good. And I hope you can hear the audio.
It says Arctic and pristine and untouched. And it looks that way on pictures, but once you get here,
can you hear this okay?
Yeah, a little louder would be good.
You get a completely other picture. Just last year, I think we took 30 tons brought in. household litter, food wrapping, bottles. But the main part, weight-wise, is equipment from fisheries. Lots and lots and lots of pieces of rope. Some are cut, some are obviously torn. The international fishing fleet is operating offshore, and we clearly find signs that they contribute to this. But still, we find litter from all over Europe, and even some from across the Atlantic. I mean, you can throw a thing into the ocean in Florida and think, oh, I've thrown it away. And then it might end up here in our shores. They rather quickly break down into smaller pieces and even tiny little fibers. I think the coastline as a whole is, I think you can characterize it as a microplastic factory. Yeah, what to say? It's so obvious that what we are doing here is not like the tip of the iceberg, but it's the visible tip, really. This is what is readily available. I mean, I pick up this little piece of litter, and it's gone down. It won't go out to sea again. It helps.
Great, thank you. So that worked.
Good.
And was a great overview from Norway. So back to the slides. And then we have a few more minutes, and I'm sure there are also many questions on the topic. Hopefully, we still have some time for questions afterwards.
Sure. The Arctic Council is seized with this issue, as they say in the diplomatic world. And the Fairbanks Declaration at the end of the US chairmanship last year produced a point that, I just lost the word in English, called on the PAIM working group, the Protection of the Arctic Marine Environment working group, to take a look at what was happening with plastic, how much was coming in, and to assess the scope of the problem, and to figure out what steps the Arctic Council might take collectively to deal with this problem in the region. The map that you're seeing is something that we produced as part of a desktop study, a literature survey that my colleague Joan Fabris has been leading with a number of other colleagues, and they're right in the middle of this work now. And so what they did was took as much data as they could find and cobbled together this map, and what it shows is the sources of plastic debris coming into the Arctic, and maps it, pardon me, maps it with the ocean currents. This is a pretty crude first draft. I think they would be embarrassed if if they found out that I was showing it to you. But this will be a revised version of this will be part of the study. But what it shows is where there's a correlation, obviously, between population and the production of waste. So most people living on the periphery of the Arctic are in this part of Europe, and in the Baltic area where material gets flushed out, and then on the west coast of Alaska. Where there are small populations, there's it's hard to tell what river sources there might be. But if you remember the first slide I showed of that field, the water and the field of wood debris, and then right after that was a plastic bottle. That's about 150 kilometers from the mouth of the Mackenzie River. Last summer we were up there on a voyage, and the Mackenzie River flushes millions of tons of wood out into the Arctic Ocean every year. It's one of the largest river systems in the world, and out with it comes plastic. And or plastic gets dumped off boats or whatever in the region, and it all gets washed up on the shore there. So it's definitely happening. The PAIM report is actually going to look at how to develop a regional action plan that the countries would then sign on to deal with plastic waste in the Arctic. And that will, of course, involve dealing with it at source. So some of these campaigns that are already underway, restricting the use of plastic straws, substituting plastic for other materials, etc. It's much easier to deal with plastic in the environment if you can deal with it at source rather than once it's in the environment, and especially once it's in the ocean. So these are the objectives of the study. Increasing knowledge and awareness is number one in all of the work that's going on. And that's actually one of the interesting things, I think, that's happening. And I'll just conclude on that point in a moment, but there'll be some recommendations as well in this study, including its major focus is its gap analysis. Like, what do we know, rounding up the literature, and where are the gaps? And the gaps are pretty big. There's been research on fulmars and a couple of bird species, and they track the amount of plastic over years in their guts. But there's big geographical areas where there's been no study done whatsoever. Many species have not been examined. So this is a long-term project that has to happen quickly as the problem is getting worse. So this is also something that is a global issue. And every couple of years, UN Environment has a General Assembly, Environmental Assembly, and last year's focus was on pollution of all sorts, and there was a reference to the amount of plastic that's dumped into the environment. There are a number of side events and resolutions, and in the end, there was a resolution that countries would work together collaboratively to tackle plastic pollution. As awareness increases, so does false news, so to speak. We recently did a project for the Ministry of Environment here in Norway, where they wanted us to do some research and we wound up busting 10 myths about plastic. And the number one is always, there's nothing I can do. It's way too difficult. I think that there's specific messages that can be put out around this issue that will encourage action. The action doesn't need to be massive. The video of the gentleman in northern Norway is I think indicative, because beach cleanup actually is a useful action. You think, yeah, you clean up the beach and it's trashed the next week, but Norway's been running for 7 years now a beach cleanup program in all the schools, and there's several schools around here that participate. And they collect tons every spring. They make wonderful sculptures out of it, art projects. We ran a painting contest for some of the younger students, and all of that contributes to awareness raising and changing behavior. And the behaviors that need to change, for people in our age groups, but also the best approach is always in any of this kind of environmental advocacy work is to reach out to young people. And even before you have to change behavior, you help form behavior and help them see the world in a different way that will lead to the kinds of behaviors that will reduce the impact on the environment ultimately. And also maybe help them put into power leaders that will take action rather than just talk about taking action, but that's perhaps just another opinion. There's action I mentioned Kenya and the plastic bags. Maharashtra state in India has banned single-use plastic. Maybe we're on the verge of something that's kind of like smoking. There's once upon a time nobody thought smoking was a big deal, and once the data started to be assembled, a momentum was created to make a change in people's habits and recognition of health impacts, et cetera. And despite the fact that there was a massive lobby campaign and a well-funded campaign for years and years by the tobacco companies to counter all the science, nobody's really trying to counter the science in plastic. In fact, it's in the interests of companies that are producing plastic to get on board and produce materials that either break down more rapidly or work on developing substitutes, et cetera. So I just want to leave you with a couple of sources. You can find this on our website. This is the graphics document that I showed earlier, and the debunking fake news marine litter website. You're welcome to dip into that and wow your friends at the dinner table or cocktail party. And you can find all of that material on our website at greta.no. And that's my presentation, and I'm happy to answer any questions or have a discussion, whatever you like. Thanks very much.
Well, thank you, John. That was really, really interesting and also, of course, moving. I have to say, just my first question to you. I mean, you showed the two avenues, right? One, stopping it at the source, and the other one is removal after the fact. And just looking at the effort that is necessary, would you say that removing marine litter ex post, basically after it's already in the sea, is more part of awareness raising, or is it actually possible, considering the low density of the litter in a lot of the water, is it actually possible to have an impact to actually physically lower the amount of plastic in the ocean by removal technology? Or should we focus entirely with our action on stopping it at the source?
Yeah, that's a really good question. There is a big debate about removal technology, and it's like geoengineering climate change. You know, we're in this fix. We'll find a technical solution that will solve the problem for us. That's not going to happen. Technologies applied in this area. There's a strong possibility that they can only cover a certain amount of area, and that there's negative impacts from the process of scooping the plastic out. Plastic is not all lying in a single layer like this. It's many, tens, 20, hundreds of meters in the water column. So you can't possibly get it all. So the investment in that kind of process, that money I think would be much better spent on awareness raising and trying to deal with it at source. Because once it gets into the environment, it's in the environment. And as I mentioned, I think cleaning up a beach is a very good awareness raising effort. Yes, you take, on a weekend, you might take 5 tons off the beach, and that's kind of what we do around here because we're on Skagerrak coastline, and it's a major transportation route out of all the ships coming out of the Baltic and heading to the North Sea go by here. So a lot of rubbish washes up here. But I think it really is an attitude change that will drive consumer change. If consumers start saying, I'm not shopping here because you guys have too much plastic, in our system, that will have an effect. But ultimately, the problem is us. It's like every other environmental problem we face. It's like climate change. This didn't suddenly happen. It's because we have made, as a societies, we've made choices about how we want to live and how we want to use our resources and how we want to use the planet. And we are now at a point where we can no longer afford to continue operating that way. And I think plastic is a really good proxy almost for other environmental decisions that we need to be thinking about. So I think the more emphasis we can put on, creating a different culture and a different approach to how we live in our society, the better. So I think that's a long-winded way of saying stopping at source.
Great. Well, thank you very much for answering my tricky question. And John, we still have a few questions from the audience, and I want to give the microphone first to Dario. Dario, you can speak now if it works where you are. You can ask your question. Okay, I'll give you 2 more seconds. If not, since you sent the question, I can also ask the question directly. Okay, so Dario has a question on the communication aspect of marine litter. How do we assure an effective communication?
Yeah, that's a good question too, because we wrestle with that one all of the time. It's pretty easy to put information out there. That's our job. But how you actually communicate in a way that will change people's attitudes and behaviors. That's the trick. I think really the best communications tool you have is a story. If you can tell a story about something in a way that connects your audience, then you'll get an emotional response. Human beings, we don't make decisions based on facts, even though we like to think of ourselves as, in the scientific age and post-enlightenment, et cetera, et cetera. Think about some of the decisions that have been made in the last couple of years around this planet. I might be thinking of the election in the US, where millions of people voted against, their real interests, but because they voted with their guts. I come from a province in Canada where government just changed and a populist government was elected and people voted with their guts. So we always react to things emotionally. So and I'm not talking about manipulating people, I'm talking about making a connection. I think there's a real difference. In this business, we need to be able to understand how people respond, what their interests are, what their concerns are, what their values are. So you really need to understand your audience. So you can broadcast information, and that may make some people respond, but you need to, and I'm talking about just this, the scientific information, but you really need to be able to look at what are the methods you're using to convey that information. So I thought that when I talked to Max yesterday, I said, I'm not going to use any video. And then I remembered this video of this beautiful booked cove in northern Norway, and with this guy picking up the plastic. He's there by himself. There's no, there's kind of this blue patina to everything, and there was a sense of, at first desperation and hopelessness, but then that kind of evolved into something quite positive, because he's saying, I'm going to do it. Everything I do makes a difference. And so I think that's the kind of trajectory you need for communications. But it's not easy. I mean, it's hard work, and you have to keep repeating the message, and repeating the message, kind of like I've just done.
Great. We do have another raised hand from Vanamali, and if your microphone works, I hope you can ask your question directly.
Okay, I'll try. Can you hear me well?
Yes, it works.
Okay, great. So there are no doubts that there are plastics and that we need to clean up the plastics and all that. But I feel that there's a discrepancy between policy, because we have heard about the policies in Africa, but the Arctic nations and the observing nations like China and India that we talked about producing a lot of plastics or using a lot of plastics. So how much political power does the Arctic Council have to tell these countries to stop using plastic bottles or products, or even have some sort of a ban? Like if these nations are trying to be part of Arctic Council, or have some sort of a influence, then how are they contributing? Because the global ocean currents are not stopping in any country's boundaries. And if you follow the global currents, the plastics are coming all the way to the poles. Mm-hmm. So how much power does the Arctic Council have to make the Arctic observing nations to do something about it?
That's an excellent question, and you've put your finger right on the problem with the Arctic Council, and that is it has no political power. It has the power of persuasion. It has the power of, having just made this argument for communicating, making connections and telling stories. It also has the power of research and information. And it's been successful in the past getting its data and information into global processes. And I alluded to the persistent organic pollutants treaty negotiating process in the late 90s and early 2000s that led to the Stockholm Treaty. So that's a way of influencing collectively global policy. When it comes to actually dealing with something in their own backyard, I think for the Arctic Council, the research that is going to be conducted probably over the next, I would say, 5 or 6 years. Once this first study is put out, there'll be a discussion and an evaluation, and the Arctic Council will work on an action plan. The Arctic Council is not a treaty-based organization, so it doesn't have political power, but the Arctic Council has negotiated now 3 internationally binding treaties, or supposedly binding treaties. So it might be possible for the Council to decide collectively. That's what we're going to do with plastic and marine litter. In order to protect the Arctic environment, we are collectively going to take steps over X period of years to reduce the amount of plastic in the environment, and there'll be, we'll do it by, reducing production, changing how we use plastic in our own countries, and they can certainly encourage the observer countries, China, India, and others to participate. The Arctic Council does have a bit of leverage over those countries in the sense that their memberships are reviewed periodically. But the Council, if you're looking for an international plastics treaty led by the Arctic Council, that's not going to happen.
Well, John, thank you for that answer. And Vanamali, I hope that answered your question. Otherwise, please raise your hand again, and we'll have more time for questions hopefully afterwards. We do have one more of a comment than a question from Andreas Kramer. So I'll let you talk now if your audio works. I hear already some interesting sound coming, so you're outdoors.
Yeah. Yes, I am outdoors. This is the garden in the background. John, it's great to see you. I just wanted to make sure that everybody understands as we focus on the Arctic. I was listening to this presentation with 2 eyes and 2 ears, and one half of me was focusing on everything that you say about the Arctic, which is the interest of this Arctic Summer College. The other half of me was listening to your presentation with a background of somebody who coordinates, not coordinates, but animates an exchange between researchers on plastic in the environment. And your presentation was so good that I feel that we should use the video of it, the recording of it, and educate all of those scientists working on plastics in the environment. So thank you very much. This was a very good contribution, a very important subject in the Arctic. And yes, we do need to think about ways of putting pressure from the Arctic perspective onto the countries that produce all the plastic and then let it end up in the ocean, where it then ends up, or part of it then moves to the Arctic. We need to find ways of connecting those things, and your contribution is excellent in that respect. Thank you very much, John.
Thanks, Andreas. Pleasure to see you again and hear you.
Yeah, there you are. Should do this more often.
Where's your garden?
This is my garden in Berlin.
Ah, okay. Next time I'm in Berlin, we'll drink some wine.
Great, look forward to it.
Okay.
Excellent. And of course, we still have a few more minutes in the first session. So if you have any last minute questions, feel free to ask him now. But I also hope that John will be available for later questions if they come up. And of course, you've heard from John's presentation that there is information available at this website, greta.no. And I think that probably many of us will go to this page. Also, of course, once there will be more information about particularly the impacts in the Arctic region, in the Arctic Ocean, I find it very interesting because, of course, John, you had these global numbers of source countries for plastic pollution, but of course, these are not necessarily represented in the same proportions as contributors in the Arctic region. And then yet again, this might change over the future if the ocean currents change and we have melting sea ice. So it's very interesting because we're actually, you said, we don't have a lot of data, we need more data. And at the same time, the whole, what we observe is shifting and changing and evolving. So it's interesting in that regard, also from a science perspective, of course. What I wanted to know, since John, and no worries if you don't have that much information on this, but since a lot of people in the Arctic region depend a lot on eating be it mammals or fish from the Arctic region. And we see that microplastics and plastics that deteriorates into microplastics ends up in the food chain. Do we have already an idea what this could possibly cause or lead to in terms of human health impacts, or any indication on that?
Yeah, that's an important question, because it was one of the points that when you go into the stop talking trash about marine litter, there is a question in there on human health impacts. And what happens when you ingest microplastic? The answer is we don't know. There's concern that some plastics bind with toxic chemicals already in the environment, and then, so you take that in. In the Arctic, you would probably find, like you would here in Norway, find plastic in the stomachs of lots of fish. Is that, is that going to harm us if we eat it? Certainly your first reaction is, oh my God, I'm not touching that stuff. But I think you have to be careful with this one, because when POPs became an issue, persistent organic pollutants became an issue, the first reaction was, well, tell the Inuit and other Arctic peoples to stop eating this stuff. And there was a big pushback on that, because when you balance it out, it's still better to eat country food, as it's called, the natural food, whether that's from seals or fish or whales or other animals, but mostly we're talking about marine animals here. It's better to eat that food because it's more nutritious than the stuff you're going to buy at the store. So, but it needs to be monitored. So that means governments need to invest in monitoring the long-term health of populations. And I think we're better placed in the Arctic than we were 25 years ago when the whole POPs debate started, that there is a lot of work that's being done on human health in the Arctic. So I think it would be possible to continuously monitor it, but also you can pull in data from other places in the world where these kinds of studies are going on as well, because I guess plastic is plastic, and it's whether you eat it in Indonesia or you eat it in the Arctic, maybe it has an effect, maybe it doesn't. I continue to eat fish. When I catch a fish, I don't look in its stomach. So.
Well, thank you, John. It's also very encouraging, because I think even though this is, of course, dramatic, the pictures are dramatic, but it's also good to still see this in context, and to also still see how important the marine environment is as a food source for local populations, and how this is important also to maintain economic independence of indigenous people. And we've heard that in last year's in other presentations in the Arctic Summer College, how access to food and access to income are critical factors, and they all circle around access to what you call country food. So these are, of course, very complex systems that now are connected basically to us having, you said, a six-pack binding ring out of plastic, or a plastic straw in a cup of coffee to go. All this is fascinating and scary to see how this is linked all the way up to the polar region, but also encouraging, because what you pointed out, John, that it's all in our hands. We can actually do something about this fact. And I think I can only concur with Andreas and say that this topic, this presentation, is actually relevant way beyond the Arctic Summer College. And I'll also encourage other fellow plastic enthusiasts or plastic activists to rewatch this and also follow up on your research and publications. I do think we have about one question left in the session, if we have another question. And I do see a question, yes, from one of our presenting participants. So this is tricky because they cannot actually raise their hand because they're panelists themselves. So Autumn Lynn, you can actually talk now. If you want to ask your question, you can go ahead. I hope, yes, you're here. Great.
I'm here. Yes, thank you. Thanks so much for that presentation, John. I'm a researcher at the Smithsonian Migratory Bird Center. And as a marine conservation biologist, I really appreciated your point about broadcasting information versus communicating information to change behavior. And one thing that I've struggled with myself is how to measure the impact of our communication tools and how to understand whether we are having a behavior change response, because it's often difficult to assess, how your communications are being used and interpreted. So I'm wondering if you could comment on that as a science writer. What do you think about and how do you measure the impact of your work?
This question is something that we are wrestling with in our organization, and for a long time we associated impact with kind of a random selection of events. So somebody mentioned our work in a presentation, or the minister spoke about it on in an interview. Now we still count that stuff, but the piece about changing behavior is I think it's almost impossible to say. I don't want to be a downer, and it's not an argument to, well, you shouldn't try, because I think that this work is so complicated and there's so many people involved that we can't really tell what is the contribution that we each individually are making. To try to answer this question, we entered a contract just a couple of weeks ago with a company that's going to, ironically called Meltwater, that's going to track both our social media and our editorial impact. So editorial being anything that might be in a newspaper or anything that gets mentioned in a government report, primarily in Norway, a little bit in Europe, because we want to actually we want to get some data on where is the information actually being used, and then that will allow us presumably to follow up and try to figure out a way to track the impact a little more directly. We've done a study as well on one particular project, which we actually had to put some resources to it. Basically, we have a number of interns in our organization, and we dedicated the time of an intern to chasing down all the connections that were made to this particular piece of work. So in the end, you have to rely on your own integrity, your own professionalism, and the quality of the science, the quality of the knowledge, and just, I hate to say give it your best shot, but I think communications is tough. Communications is probably easier than changing behavior. So I'm sorry I can't give you a definite answer. I've often wished I had a magic wand, because I've certainly railed about people not, like, why is it we don't understand what's happening? Why do we continue to foul our nests? What's the matter with us as a species? Those are fundamental questions, I think, but when we're looking for change, we have to look as well for examples of things that are happening positively. So it's pretty easy, and I wanted to actually, when Max was speaking earlier, it made me think of the other person who asked about communications. It's really easy to focus on the negative stuff, on the cataclysmic and the catastrophic. And I started this presentation by doing just that, because it's an attention grabber, but we're also becoming very numb, I think, to these stories. And so what is the answer then, to amp up the threat, or is it to actually look for, again, I go back to the idea of stories, some positive examples of change that you may not have done, you may not be directly responsible for it, but it's something you can point to say, this is the kind of thing that needs to happen and we need more of it. I'm not sure that answered your question though.
No, it was helpful to hear your perspectives on that, because I've often thought that it would be very difficult to actually measure impacts because there are so many players, and you never know the cumulative impacts of all of those different pieces of communication. But it's helpful to hear that from you. Thank you.
I'm actually I'm shocked to hear you. So the Smithsonian hasn't figured this out?
I think, you know, in the museums, the Smithsonian does focus on that quite a lot. You know, what is the impact to a visitor to a museum of a particular interpretation of science? But the research centers, which are mostly full of scientists, I think, you know, putting out scientific publications and occasionally doing outreach, that's a little bit different.
Yeah.
Not quite as direct of a, you know, response from audience to a particular message. So, yeah.
Well, I think it's a great topic and probably relevant for, if not all, at least most of us here on this webinar. It's very challenging, especially if there's a time lag between receiving information and then something building up. And but I think above all, we have to really stay on track and be working towards, even if it's in small steps, towards progress on that matter. And I think also your presentation, John, was really wonderful to both introduce this in the Arctic setting, but also overall. And I think you can really tell your years-long experience as science communicator, science writer, that you can really tell the story, the narrative, including the bad, which is true, reality, but also something positive, encouraging, and action-oriented, which is necessary so people are not stunned, like I would say, like a deer in the headlights of an incoming car. So we want to be active. Thank you so much, John. You're more than welcome to stay on and also ask very difficult questions to the next three presenters. And,
is one of them Andreas?
Not exactly, but you can still ask him questions. We can even make this an option later on, definitely. So we also want to have conversation happening. That's great. So I will switch.
I would like to do it, but I'm afraid that my wife is waiting downstairs and we're going to have dinner. So
fair game. That's absolutely a good reason to excuse yourself. I hope we'll be in touch. I hope we can see you another time here at the Arctic Summer College, and want to thank you and also wish you bon appetit and enjoy your summer in Norway. Thank you.
Okay. Thanks everybody.
Thank you. And I will, thank you so much. So we have now the second hour of our Arctic Summer College, and this is of course a little bit of a novelty in many ways, because now we turn over to the group presentation, which in this case is not entirely a group presentation. It's a series of presentations on the topic of environmental change in the Arctic. And I do think you had it relatively challenging since you started the Arctic Summer College only 2 weeks ago, and now is already the first group presentation. You're also, in a way, of course, the first ones you couldn't really see what other people are doing. So we have actually 3 presentations that will come one after another. They're each a little bit shorter than what John had. And so we have enough time to also have a conversation. I want to thank you, first of all, well, for preparing this for today. I hope you found this also an interesting experience to work on this. And I will now yield the floor first to our first speaker, Mariana, joining us here. You already have your screen shared, so the presentation is on there. And once you go into the full screen mode of the slideshow, then we can see the full screen presentation. You should be able to already work on the slides. So your topic is right on the first slide that we see here, Arctic sea ice monitoring. And we tested the audio. It worked before. I trust that it will work now too. Mariana, do you have any questions, or are we good to go.
First question would be if you can hear me.
Yes, we
Okay.
can hear you really
work.
well.
Okay,
That
so no, I guess I can start with the presentation, and I'm actually quite relieved that John left, because when you said please ask difficult questions, and I'm being the first one, I got all nervous, so that's a bit of a relief for me. And also, yeah, so I can start actually, and we can proceed.
Perfect. So yeah, currently I think there's a PowerPoint, so we're not in the presentation mode yet. If you switch into that, then we have it in a larger format on the screens. So so that looks good. Black screen is good. I'll disappear now, but I'll be back whenever there's an issue. Thank you.
Okay. So I'm not sure if I'm on camera now or not.
Yes, you are. You are. We see you, and we see the slideshow. It fell out of the slideshow again.
Okay.
So if you
I will just switch off
again.
the webcam because first of all, because I want just to hide the fact that I'm will be looking in my notes, and also because I probably will get confused all with the technology. So I'll switch it on after I'm done with the presentation.
Very good. Very good.
Okay. So I hope you can still see the presentation though.
Yeah, it's still coming on. So now it's here. Perfect. Perfect.
So probably the first thing that I should be mentioning is that I am not an Arctic scientist. My focus is a bit different. I'm actually working, the last years I've been working in the Caucasus and Central Asia, and you're probably now wondering, Central Asia and Caucasus, how's that related to the Arctic? It is not related, and but I have a strong interest in this field that was already that I had since my studies. And I'm actually intending to work more on this, to focus more on this region. So this would be like my first step. So don't be too critical on me. Also because I'm being the experimental rabbit here. So the first one who's starting the session. So yeah, well, now I will go into my session. So as you can see, I will be presenting about Arctic sea ice. And the first slide, you can see the political map of the Arctic region with the main Arctic countries. On the right, you can see a map of the Arctic Ocean with the main parts of the Arctic Ocean, so the different seas. And the Arctic Ocean is the smallest and shallowest of the world's 5 major oceans. It is partly covered by sea ice throughout the year and almost completely in winter. The Arctic Ocean surface temperature and salinity vary seasonally as the ice cover melts and freezes. So the salinity of the Arctic Ocean is the lowest on average of the 5 major oceans due to low evaporation, heavy fresh water inflow from rivers and streams, and limited connection and outflow to surrounding oceanic waters with higher salinity. So here on this picture, you can see the vertical distribution of the major water masses in the Arctic Ocean based on a hypothetical transect, which is indicated by the black line on the map, on the circle on the right. So here, if you can see my mouse moving. So the typical vertical distribution of potential temperature you can see on the left and of the salinity on the right. In large parts of the Arctic Ocean, the top layer, which is about 50 meters, is of lower salinity and lower temperature than the rest. It remains relatively stable because the salinity effect on density is bigger than the temperature effect. So it is fed by the freshwater input of the big Siberian and Canadian streams, the water of which quasi floats on the saltier, denser, and deeper ocean water. And between this lower salinity layer and the main, you can say, bulk of the ocean lies the so-called halocline. So you can see here the Pacific halocline and the Atlantic halocline, in which both the salinity and temperature are rising with the increasing depth. So the Arctic Sea, the Arctic ice covers the Arctic Ocean and its vicinity. It undergoes a regular seasonal cycle in which ice melts in spring and summer. The summer ice cover in the Arctic is about 50% of the winter cover. So currently 28% of the Arctic basin sea ice is a multi-year ice, and it's thicker than seasonal ice. So the seasonal variations are about 7 million square kilometers, with the maximum in April and the minimum in September. The sea ice is affected. The sea ice is affected by different factors, but the most important ones and significant ones are wind and the ocean currents, which can move and rotate very large areas of ice. So here you see an animation track of seasonal Arctic ice melt with winter maximum in April and summer minimum in September for the year 2017. It shows monthly sea ice concentration from April till August for the year, for the last year. And on the, can you, I don't know if you can see the animation. I hope you can.
Yes, it works.
Okay, great, it works. The final frame shows sea ice concentration on the date of the likely minimum extent on September 13. So the sea ice ranges from white, which means the highest concentration, to dark blue, which is the lowest concentration. And the yellow line is the median ice age for the climatological average. So why did I choose this year? So following an exceptionally warm autumn and winter, it was the lowest Arctic sea ice extent maximum in the satellite record. From about the second week of June through the first week of August, the overall Arctic sea ice melt rate nearly matched that of 2012. And it was the year of the lowest Arctic minimum extent on record. So you can see that monitoring the such monitorings is very important to give analysis about how the development of the ice will be happening. So that's why it is very important to use monitoring data for analysis of changes in the sea ice. However, despite the technological development and the satellite era being improving and enabling better measurement of trends, especially in aerial extent, however, accurate ice thickness measurements still remain a challenge. So therefore, both the sea ice area and extent are still estimated. However, a computer-based time-resolved calculation of sea ice volume, which is fitted to various measurements, revealed that monitoring the sea ice, the ice volume is much more significant for evaluating sea ice loss than just pure area considerations. So, as an example, on the right you see a picture, which is an example for different sea ice monitoring technologies. This picture shows the Alfred Wegener Institute Sea Ice Thickness Sensor, EM-BIRD, during a measurement flight across Arctic sea ice. And this photo was taken on board the German research aircraft, Polar 5. And this image was taken during the sea ice measurement campaign in the year 2009.
Marianne, just very quickly that we are time limited for this session because we have the 3 presentations. So if you can maybe cover this in 3-4 more minutes, or then that's perfect. I don't want to rush you too much.
Yeah, no, I will try to be fast. So, okay. I will rush through the other slides. Well, let's try that. So you can see that also despite that monitoring is being very important, there is though serious challenges for scientific monitoring in the Arctic Ocean, which is mainly through extreme conditions of temperature and nature, and also because it's permanently covered by ice. So it is difficult for research by vessel, and obviously also very expensive. So there is a sea ice loss that is observed in the recent decades in the Arctic Ocean. Due to, however, sea ice in the Arctic, due to its interaction with atmosphere and ocean, is a critical element in climate process in early warning system for global warming. And the IPCC report concluded with high confidence that the sea ice continues to decrease in extent. So I will rush through this one, probably because we can skip this one. I'll just go straight to this picture. And this maps on the slide compare the Arctic ice minimum extents from 2012 on the top and 1984. In 1984, the sea ice extent was roughly the average of the minimum from 1979 to 2000, and it was rather a typical year. However, the minimum sea ice extent in 2012 was roughly half of that average. So you can see it's actually a huge decrease. So, well, the extent of it can be said that the extent of the Arctic sea ice shrank to roughly 4.7 million kilometers, and the September minimum extent is an important indicator of climate change. And yeah. And well, yeah, so the sea ice coverage in March 2017 was lower than any March before recorded, and also in any of the previous years. Okay. So maybe this graph will be quite interesting to see as well, because on this graph you can see the stable decrease of the sea ice for the last, let's say, roughly 30 years, with, as mentioned before, 2012 being the lowest year, which is very visible here. So are we heading to ice-free summers? Well, with the continuation of the current rate of the sea ice retreat, the Arctic Ocean might change from a permanent to a seasonally ice-covered ocean, more typical for subarctic areas. And the IPCC estimates an ice-free summer might occur around the year 2050. And yeah, well, the conclusion is that a summertime ice-free Arctic would be unprecedented in recent geological history, as currently scientific evidence does not indicate an ice-free polar sea anytime in the last 700,000 years. Okay, so I'm done.
Wow, wonderful. Thank you so much, and apologies, Mariana. I know that this is always very challenging, especially since we started a little bit delayed into the second hour. I appreciate you made a on-time landing here. Perfect. I hope we have some more time afterwards for questions also about your presentation. I'll first hand over now to our next presenter and ask Alexis to get ready and get slides up. I hope your webcam is also ready. Perfect. So Alexis Garretson discussing Arctic vegetation. Everything looks perfect. We can see your video and the slides. And I leave the floor to you. Thank you for presenting.
Thanks so much. Can you hear me all right?
Yes, yes.
Perfect. So my name is Alexis Garretson, and I am primarily a quantitative ecologist. So I'm interested in developing methods and applying methods to analyze different ecological communities. And so right now I'm interested in applying that to Arctic vegetation. And so when people typically think about Arctic vegetation, the first thing that I always hear is about the Boreal Forests. They're kind of, those iconic parts of Arctic vegetation. And there's actually three forest types. You have the farthest in the north, you have the forest tundra. And then you sort of, as you come farther south, you end up with the lichen woodland. And then farthest to the south, you end up with a closed forest. And so that sort of relates to the amount of temperature and energy needed to sustain different types of forest. The dominant characteristic, sort of the iconic thing about boreal forests, is that the tree stands are roughly the same size, very even, and that's really due to the cycle of natural burning and outbreaks of different insects that can take down the populations sort of at a constant rate. Prior to the colonization and the modern firefighting systems, the burn cycle was usually about 75 to 100 years, which it still is in many areas, but that's definitely changed. I'm a little bit less interested in the boreal forests, and I'm more interested in some of the other vegetation diversity you get in the Arctic. So even though the South does support some of the tall and really dense tree vegetation, the northern areas are much shorter and very sparse. So you end up with more grasses and lichen and some short flowering plants like you see here. And there's also a good deal of algae in different parts. That's not algae in different mosses. That's not necessarily my area of expertise, so I'm going to gloss over it a little bit, but there definitely is lots of biomass related to that in the Arctic region. There's, even in the tundra, where people tend to think less about plants and vegetation, there's about 2,000 species of plants, and they're all sort of known to have short roots because of the permafrost really taking up most of the lower levels of the soil layers. So most plants in the Arctic region have really short, shallow roots. And there's a couple different adaptations that help these vascular plants be adapted to the Arctic region. Most of them have to do with protection against freezing and are either cellular level or they're structural. So most of the shrubs and grasses and sort of small plants in the northern regions tend to grow really close together, have very shallow roots, have waxy and very small leaves. It's very similar to what we see in desert vegetation, unsurprisingly. There's really difficult moisture conditions in both types of regions. The other thing about the Arctic is they're very fine-tuned phenologically. So that means that the timing, there's no real margin of error for when your leaves come out and when you sort of flush your flowers, because if you come out too early, you're frozen. If you come out too late, you're frozen. So they're very fine-tuned in terms of their natural cycles. So the extent of different types of plants in the Arctic varies. And so these maps show where different plant species are found, or different plant taxa are found. So A over here, this shows the needle-leaf evergreens. As you can see, they sort of follow, as we were talking about before, the boreal forest region. And then this region here is the needle-leaf deciduous, and so they're really far, far down. And that's because deciduous trees tend to not make it when it gets too cold because of the cycles that you need to have. So this too is the broadleaf deciduous, and as I mentioned, it's much further down in order to accommodate the cycling of leaves. Over here are crops, and so we can talk a bit more about this because lots of people are often interested in the changing agricultural climate in the Arctic. But these are the regions really that can grow crops, and you see there's a little bit up here in Canada, but most of the Arctic region is unable to support most crops. This is interesting to me. I think grasses are some of the coolest vegetation in the Arctic, and you can see that they're really dense even in places that you wouldn't expect to find much vegetation. And then this map here shows some of the bare soil. So as you get further north, you end up with high levels of bare soil. And so the progression is directly related to the amount of warmth available for growth. Let's see. And so these two indices show a little bit about how plants are distributed across the Arctic region. This here is the above ground plant biomass. And so that's just sort of how much plant matter is sort of on the top level. And as you can see, it follows those patterns we were just talking about. This is the Ndvi Index for the area. This is the normalized difference vegetation index, and it's created from satellite imagery that measures the sort of reflective index of different plants. And so because of the short growing season, these really change throughout the year. and there's strong controls, especially from temperature on and topography on the types of plants that grow different places. So in the Arctic, there are a bunch of different floristic provinces, and so these are different taxonomic zones where different plants are known to be found. And as you can see, this graphic here shows you what percentage of the vascular plants that are found in the Arctic are found in that region. So you can see that there's pretty good diversity of where the Arctic plants are found. So there's a total of about 2,000, as I was mentioning before. The counts kind of vary depending on who you ask, but there is about 2,000 different species of floristic plants. And there are 9 endemic species that you can find throughout the region. So this map sort of shows you how they're distributed in the different regions of the Arctic. So over time, especially in the past couple decades, there's been a big shift from much more bare land and sort of grasses to a huge greening shift. So this map is pretty interesting. It's from the American Museum of Natural History, and it shows sort of how drastically you've seen this shift from mostly less green to a lot more green in the polar region. And so this is happening a lot because of the temperature changes and the changes in the vegetation that's able to be sustained in those regions. Something that I think is important, especially later on in this conversation, is the start date for the BEN. So what you see here is it starts in 1982, which is because that's really when we had good satellite imagery to create these sorts of indices. But when we think about sort of vegetation shifts due to climate, we like to start a lot earlier, about the 1960s. And so we don't have tons of data from the Arctic region that go back far enough to really see what the impact of the past couple decades of changing climate has been. So in the high north latitudes, it's the predominant vegetation has become greener. It's become much more productive, with pretty low productivity here. And as climate changes, you can see the expansion of the boreal forests into much more northern regions. And so what's interesting is that this creates a feedback effect. So because the plants are much darker than the snow or the ice, it absorbs more sunlight, and so you get sort of this intensified warming effect. So the trees are darker, it absorbs more light, it's warmer, more things can grow and expand even further. And so one of the things I'm particularly interested in is in the circular models of different natural events. And so I'm particularly interested in Arctic phenology. And so phenology is the cycle of natural events, especially in vascular plants. But it's sort of, when do you start hearing birds singing? When do you start seeing leaves on trees? And so in the Arctic, that's really strongly controlled by the snow melt. And so when the snow melts, that's when things start popping up out of the ground. And so typically the Arctic phenological seasons are broken into the snow melting, the end of melting, and then the green up. That's really when leaves start being flushed, flowers start coming out. And then the peak season is sort of the ideal time for plants to be reproductively active. Many plants in the Arctic are reproduce through wind scattered seeds because it's pretty energetically intensive to do other types of reproduction. And many also reproduce asexually, but the peak time for that is during this sort of August time here. Day of year isn't necessarily an intuitive measure for most people, but as you can see, it sort of peaks in this general late summer timing. And then after the peak season, there's a green down, and then you get more snow. So what this looks like is a really intensified and very shortened version of what happens all over the world. And so this sort of peak right here is much shorter than you'd see in most other regions. And so one of the questions that my group is interested in is, how can we think about how these shifts will affect different species? And so as I mentioned earlier, there are some pretty strong limitations on the types of data we have. So past studies of Arctic vegetation have either been sort of satellite based, which really only were feasible starting in the 70s and 80s. And then prior to that, we had some sort of moment in time snapshots where we could see, oh, at this point in time, this is what was happening in this very specific region in these plots we set up. But we don't necessarily have a comprehensive longitudinal data set where we can say, over time, this has been shifting. These are the things that are happening to plant species. So part of my work is using digitized herbarium specimens seen here to sort of see how these shifts are occurring and what they look like. So this is the pasque flower, which is native to the Arctic. You can also find it in other parts of North America, but it is sort of one of those really iconic, pretty Arctic plants. And so these different herbarium record sheets are from all across the 1900s. But what's nice about them is that it lets us sort of have time capsule back in time. So these two records are actually from prior to 1950, which is much earlier than most of our data sets are able to go. And so what we're interested in sort of how are the length of stems changing? Because as I mentioned earlier, one of the adaptations in the Arctic is short, stocky little plants with really short roots. And so if we can see over time, how is the length and the height of different plants changing? How are their roots changing? How are their colors changing? So as I said, that different colors absorb more or less sunlight. And so we might expect a shift in the colors of the flowers that are being flushed by different plants. And so my research is really thinking about how can we think creatively about getting past specimens into a longitudinal data set so that we can think about a longer time span for the Arctic. Because it really is clear that something's going on, that there's been this larger trend of changing forest and vegetation dynamics. And so it's critical to sort of be able to think what the natural state would be so that we can think about how quickly or how different things are changing now. And that's it for me. I think there's a little bit more time for questions if there's anyone that would like to ask.
Yes, great. And Alexis, we will skip this questions moment right now and put that to the end along with Mariana. So just so we don't risk cutting Autumn Lynn short of her presentation option, and then we will have like a mixed bag, but we'll definitely come back to you. I want to thank you. It was very interesting. And I want to just hand over as smoothly as possible to Autumn Lynn. I hope you're already warmed up and ready for presenting. So you can already share your screen. That works, and the presentation is on. So Autumn Lynn, thank you. Oh, now it's gone again. We just had the presentation up.
It's coming back.
It's coming back. So here we are. Yes. So thank you very much, and the floor is yours.
Thank you. Can you, you can also see the control panel, correct? Are you just viewing the PDF?
Yes, we see also the control panel,
okay.
But we see a large picture of the PDF.
Okay, good. Okay, good. Well, as I've introduced myself, I'm a research ecologist at the Smithsonian Migratory Bird Center. I'm trained as a marine ecologist, and because I study dynamic processes like animal migration, my talk today really benefits a lot from the presentations of Mariana and Alexis. They both provided a good foundation for the principles of migrating animals. So thank you so much for that. And in this little talk, I'll give you a crash course in Arctic animal migrations. Why do animals migrate, travel from pole to pole just to survive? Which Arctic animals migrate? What are the implications of a changing environment, including changing phenology of vegetation and changing ice? And how do biologists like me study all of this? As both Mariana and Alexis mentioned, there are challenges for living in the Arctic and for animals, and they really have to do with the short growing season, low precipitation, in some cases long, cold, dark winters with ice-covered oceans. There's some benefit to some of these challenges as well. In the short growing season, you have an explosion of life in the Arctic, and so that provides a nursery ground for many species. And animals can move, so they have the added advantage over Alexis's plants of being able to go where there is good weather, to avoid harsh weather. And so they can move to avoid this, to find food, to find a place to breed, or to avoid predators. And this is a Pacific loon, one of the Arctic species that I study. And so actually most Arctic wildlife do migrate. And when I say wildlife, I mean really the higher order animals. So marine mammals, big mammals, most birds, very few birds stay in the Arctic all year round. So most Arctic wildlife migrate when the going gets tough in the Arctic. And it's worth the effort to survive and reproduce. So many migrating animals have morphologies that let them make these long journeys with the least amount of energy possible, and they are really amazing athletes. So in a sense, many Arctic animals follow a cycle of an endless summer. They go to the Arctic for the summer, then they go to either temperate zones, the equator, or even the Antarctic for its summer. And so in the next series of slides, I'll just show you examples from different groups of animals and migratory pathways from the Arctic to the rest of the world. I primarily work in Alaska, so a lot of these examples are from Alaska. But this just to show you that migrating animals are truly a global responsibility and global heritage. We all share them, and Arctic peoples are stewards of them for certain times of the year before they disperse to the rest of the globe. And so here is just a photograph depiction of migratory pathways of 13 species of birds from Alaska connecting the entire planet to the Alaskan Arctic during the breeding season. Marine mammals also migrate usually in response to ice breakup. And in this image, we see a bowhead whale, which is part of the subsistence hunt in Alaska, and their movements between Canada, Alaska, and Russia throughout the year. On the next slide, caribou, of course, one of the most famous migratory animals of the Arctic. And the map here shows the border between the United States and Canada at the Alaska and Yukon border, and the transboundary movements of caribou between the Arctic National Wildlife Refuge and the Yukon. And not to be omitted are the fish. One of the most famous migratory pathways of an Arctic fish that we know of so far is, of course, the cod, Norway's treasure gem. And the term for the cod in Norway actually does come from the word for wanderer, or at least that's what I'm told. And here is shown the spawning migration to Norway. And I think as the Arctic becomes more ice-free, we will discover quite a lot more marine migrations of fish that move under the ice. Many Arctic migratory animals are important commercially, culturally, ecologically. On the left is a photograph I took the bowhead whale hunt in Utkavik, Alaska, which is formerly known as Barrow. And when the whale was brought in, the kids just climb on it and slide on it, and they came up to me and said, "Whale is our medicine," so very culturally important. And then drying cod in Norway, very, very economically important as well as important culturally. And since animal migration is really a response to the environment, the annual cycles of the environment, a changing environment will of course result in changes in animal distributions and migrations. And because many of these animals are so important to Arctic communities and also important globally, these changes in animal distribution will of course affect human well-being, industry, and governance and politics. And I'll just show you a couple examples here, one for avian fauna for birds and then another for fish. The maps on the left here are similar to those shown by Alexis, showing the current suitability for tree species, aspen, 1971 to 2000 at the top, and the dark green is the climate suitability for that species now. And then the predicted suitability on the bottom, 2071 to 2100 of aspen moving north. And this has the potential to replace tundra habitat with trees. Currently, shrubs are already encroaching on Alaskan tundra habitats, and we're starting to see the shrubbing up of the tundra in Alaska. And so the plot on the right, or the infographic on the right, is from a published paper in 2015 that a group of folks modeled which species of animals would gain habitat as the shrubbiness and the forest encroach upon the tundra, and which would be the biggest habitat losers. And so some of the iconic species that utilize the tundra and that are also important for subsistence hunt, like the snowy owl, the greater white-fronted goose, the ptarmigan, the caribou, those are all predicted to lose a substantial amount of habitat as the vegetation changes in the Arctic. And another example from Scandinavia of a plot that shows distributions of Arctic fishes in purple, central marine biota in orange, and then Atlantic fishes in red between 2004 and 2012. And the take-home message from this is that Arctic fishes are being really, their range is being contracted and pushed slightly northward, and then the Atlantic fish range is expanding quite a lot. And that will have pretty strong implications on economies, probably in a positive way, at least initially for Norway. And just in the past month, there have been a number of news articles talking both about this, the Atlanticifying of the Arctic, so the switch of the Arctic Ocean to an Atlantic Ocean ecosystem, and also the challenges faced by traditional industries like reindeer herders as new industries, copper mining and oil development, are able to make inroads in a warming Arctic. So not just changes for the animals, but of course resulting changes for people as well. And so just in the final moments of this talk, I'll show you how we study these issues and how we contribute to global discussions. So usually we go through 3 phases, discovery, analysis, and sharing. And a lot of scientists these days are able to use existing data sets. And so the discovery phase of science has, especially from a natural history perspective, isn't quite as strong. But when we're talking about Arctic animals, it's still the first step because there's still a lot that we don't know. So many Arctic migrations and even ranges of animal distributions are still completely unknown, mainly because of inaccessibility, the expense of working in remote habitats. The technology has been lacking until now. Pictured here is a beautiful seabird, a long-tailed Jaeger. And last summer, using a satellite tag, I don't know if you can see this, but there's a solar-powered small little satellite tag that is attached to the bird. I catch the bird, I'm pictured here in blue, and attach the tag, and then we track its migration for the very first time. So this is an Arctic breeding species that then for the rest of the year spent its life in Fiji and Tonga. And over the past 4 years of this work, we have recorded the first migration paths that we have for scientific knowledge of many species. And I'll show a couple of the really interesting ones. This is a black-bellied plover. This is actually a bird that whose feathers have been used for ceremonial purposes and for artistry in the Arctic, and showing populations tracked from Arctic Alaska and also Arctic Canada. So we've been working together, the Smithsonian and the Canadian Wildlife Service, to understand the migrations of the species. And then the beautiful Pacific loon, where I tracked these birds from Arctic Alaska to Russia and Japan and South Korea, and then a separate population in subarctic Alaska who instead spend their winters in Mexico. So quite a different story for the same species. And once we have this type of information, we typically try to relate migratory routes with human impacts, with planned industries, and of course to habitat and climate. So trying to predict what a changing phenology of vegetation, what impact that will have on arrival dates of migratory species, or whether they are able to successfully breed. And in this image here is shown ship pathways in Canada's Arctic with the ranges of many migratory species in Canada. So this is a typical analysis that we would conduct. And then finally, at the Smithsonian, our main objective really is to, after acquiring knowledge, to share it. And so we do a lot of presentations. I'm here presenting at Earth Optimism, which, as John mentioned, it was an attempt at flipping the conversation from negative to positive environmental stories. And then on the left, testifying at the United Nations about migratory animals moving through the Arctic and the need for a treaty for the high seas. And so that is a really quick crash course in Arctic migratory wildlife and some of the issues pertaining to their movements. Again, a transboundary resource and something that we all share. And I've put some social media links here as well if you're interested in more information.
Excellent. Well, thank you so much, Autumn Lynn. Also, very interesting presentation. I will quickly hand over to Brendan, who will ask a question.
Oh, thanks, Max. No, first of all, I'd like to say thank you very, very much to all three of our presenters today. It's always difficult to be first, and especially I want to say great job to Mariana for being the first. This is something we've never tried before, and I really appreciate it. From what we've seen today, this could be, and already has been, but I think can continue to be an exciting addition to the Arctic Summer College project. It's so interesting to find out what all each of you is doing and how that all can work together. And I also want to commend you, the three of you. I know you had a very short period of time to put together this presentation or these presentations, and I think you worked with that very well and were able to connect different aspects, work independently, but still weave together a narrative that worked as a single session quite well. I'm going to invite all three of you, Alexis, Autumn Lynn, and Mariana, to share your webcams again, because we will enter into a discussion session so that everybody can see you and chat with you. There we all are. And so now I'd like to invite everybody who's participating today to raise your hand or to let us know if you have any questions specifically for any one of our presenters, your colleagues in this forum. And I would actually like to start out with a couple of questions, Mariana, with you. One of the fascinating things that you talk about is, the trajectory of sea ice, the diminishing sea ice. And what's always interesting, or I think crucial to understand, is whether we're still in the mitigation or adaptation phase. Basically, have we already reached a tipping point? Are we beyond? Are we working in a whole new world, or is there still reason to believe that Arctic sea ice is something we can protect? I'm sorry, you seem to still be muted. I don't hear you.
So can you hear me now? Okay.
Perfect. Yeah, thank you.
Yeah, I got confused by all the, all the buttons, everything that I have to press. So yeah, to answer your question, it is until now quite uncertain. The data that we have is quite new. So you can't really, for a certain extent, speak that we reached the trigger point or the tipping point, sorry. So even the last IPCC report still states that there is not quite certainty to state that. But it can be said that with the increasing temperature and with the increasing warming years, there might be a triggering of this tipping points, and it could be also multiple tipping points that we will be reaching in future.
Well, that's interesting. That makes it difficult, but that's no. It is it's something that I find fascinating, and I think kind of in that same vein, I want to switch over to Alexis and follow up with you, because one of the things that we talk about a lot here in Europe, what we've been working on quite a bit, I think of bees in particular, is the entire ecosystem that we're dealing with, and what you're talking about with the foliage or with the vegetation in the Arctic and the significant changes there. It's not just about, even though I personally find it fascinating, the structural changes or even the color changes of the vegetation, as well as the grass is disappearing, but how that then affects what Autumn Lynn is then researching. So in terms of how the vegetation impacts the rest of the ecosystem, and we talked previously about this, like insects, how does the changing vegetation affect the animal world in a sense, or the larger ecosystem?
Right, so Autumn Lynn talked a lot about how it affects birds, and some of the insects that, so one of the interesting things that happens is we have these really specialized plants in the high Arctic that can't necessarily compete with some of the other species from farther south, because those species are great at colonizing and living in some of those warmer conditions. So one of the things we're thinking about is sort of what happens if native Arctic vegetation is replaced with invasive or non-native Arctic vegetation. And so one of the things that could intensify is outbreaks of different insect pests, especially in the boreal region. As I talked about, one of the controls on the boreal forests is sort of these outbreaks of different beetles and different pine eaters. And so thinking about how those dynamics could shift could have a really radical effect on the landscape of the vegetation in the Arctic. And one of the other interesting things is that most of the different classes of plants in the Arctic are able to expand further, and because of the changing climate, but there is some differential in the types of species that are able to do that versus unable to do that. So the changes, especially in the grasses, could have pretty substantial impacts on the larger species in the region, not only just the insects, but some of the mammals that are in the region, the birds as well. And so sort of those dynamic feedbacks could have pretty large scale and ripple effects throughout other taxa and groups.
No, that's really kind of fascinating. And Andreas just submitted a question through our chat function, and I was hoping that this could be a good transition then to you, Autumn Lynn, specifically from the presentations. You mentioned it at the beginning of your presentation that both Mariana and Alexis sort of laid a foundation that really set the stage for what you were going to talk about with animals and especially migratory birds. What can you point to some specific things that you learned or saw in these presentations that you find particularly relevant to your work, or generally speaking, how the larger picture of environmental sciences in the Arctic really does influence what you're doing specifically? So how the big picture then impacts your focus.
Yeah, thank you. It's a good question, because when you think about the big impact versus my focus, I also think about different scales at which these changes are operating. So from year to year, there are environmental differences that impact migratory species, and then over decadal timescales as well. So for example, this year, I just got back from Arctic Alaska, and it was an extremely late spring. So the ice hadn't yet melted in places where birds go to breed. And by the end of my month there, the ice had melted very rapidly, and so some of the tundra was flooded. And so basically that resulted in habitat that normally would be available to birds for breeding was unavailable this year. It seems that there is a lag between the response of the animals and the response of the environment. So the ice levels are changing, and phenology of insect outbreaks are changing. So insects are emerging earlier, at least in Arctic Alaska, but the birds haven't really caught up yet. And so they may still arrive at the same time, and they expect to be able to feed their chicks, or they expect to be able to find open tundra for breeding, and they may not. And so in those years, they skip breeding. They may go out to sea to keep foraging. They may go to another site, but if it's really holistically late spring, that won't happen. So there's really an accumulation of these changes at the population level for animals. So working up there, I really have gained an appreciation of how everything is tied together: the ice, the vegetation, the animals, and that affects our global populations of migratory species, because they aren't just Arctic animals. So yep, it's definitely seeing it happen and seeing it, how it's all linked, has been quite amazing for me.
No, it's quite fascinating. I want to invite Max to come back on if you're there. And again, any of our colleagues or anybody else of the participants from Arctic Summer College this week who have a question, who would like to make a comment, you're more than welcome to raise your hand now. But Max, did you have any questions that you wanted to bring up, or any comments about the presentations today?
Well, I hope that, I mean, I really don't have that much to say about the specific topics, because I'm by far not as much an expert or even an interested layperson, I have to say. I have to admit that I come back from a background of economics, and this is actually the field where I learn the most in the Arctic Summer College, and where I also learn the most in terms of systemic understanding, because it's actually interesting, because, you know, we try to mimic in economics organic or biological systems in some of the curves and equations in these modeling representations of the world, but it's of course very different in the approach, in the attempt to observe and learn from nature. I think that's so good to see the actual other side of looking at the same systems, right, from a natural sciences perspective. And I think bringing these different experiences together is also part of the richness of the Arctic Summer College, meaning I hope that you will also enjoy other people presenting on maybe other disciplines and other topics, just as much as I hope that everybody else who's here, maybe from policy science, maybe from economics, if there may be anybody, or other fields, has also learned and be able to understand a lot more. And I found also, I have to say, the success of the presentations very, very helpful, coming from this maybe more well-known or already heard fact about the sea ice decline to then actually the vegetation, and then to the animals. And of course, this all interconnects. This is a very great set. I'm deeply impressed. I just want to say that I hope that everybody had the opportunity to ask questions, but I just see that Dario has come with a question.
Vanamali first, yeah.
And Vanamali too, of course. I didn't want to skip that. So you have to hurry though. We're almost at the end of the time because I was talking for so long now. So Vanamali, ask your question. Please go ahead.
Okay, this question is for Autumn, Mr. Harrison. First of all, your presentation, I mean, all of your presentations were phenomenal. You know, it's just good to know that and it also connects the Arctic to the far away, or to the tropical areas almost, you know, going to Mexico or going to Japan, or going far distance towards the tropics. And having said that, the local science of those particular areas do not understand how the local ecology, the local population pollution affect the migratory birds' like winter habitat spots. So do we create any kind of awareness programs where these migratory birds nest, or they actually live during the winter months?
Yes, thanks for that. I have a good example of a really successful initiative of that. There's a large group of people that really love shorebirds. Shorebirds frolic along the beach. They make people happy. They look like they're really enjoying life, going in and out of the waves. And in the Western Hemisphere, there is a group called the Western Hemisphere Shorebird Group. And they are people who watch shorebirds all along the Western Hemisphere coastlines. So North and South America, along the coastlines of the Pacific and the Atlantic. And then they look for color bands on the legs of these birds. Normally when we band them, we put a little color bracelet around the leg. And then they report them to a common database. So when I had a satellite tagged bird that left the Arctic of Alaska and spent its winter in Peru, a place where there is a lot of development planned and ongoing, a woman in Peru called me up and said, "I see your bird, and where did it come from?" And so this group of people has been a really wonderful example of how people get excited about sharing animals across hemispheres. And there have been a number of children's books and statues in local communities. I mean, it's really quite impressive. So there are examples of that for sure.
So great.
Yeah, let me go ahead. Dario has a problem with the microphone, so I want to go ahead and read the question. But please forgive me, I'm going to take a little bit of artistic liberty here and actually expand the question, and because I think it really applies quite well to everybody here on our panel today. And that is how what you studied, what you presented today can actually serve as some sort of a crystal ball for the rest of the world. You know, what Dario pointed out specifically was that migration, animal migration, is usually a precursor to what the rest of us are going to have to do, or what we might start seeing on other parts of the planet. But I think the exact same thing can be said for vegetation, of course. And you know, I'm kind of curious, like that dark green ring that keeps you know, the boreal forests, you know, is that going to keep shrinking inwards? You know, how do you see these three areas? We'll start with Mariana. How do you see these three areas as being kind of a warning sign for the rest of us, for the planet outside of the Arctic?
So I would have to actually refer to the presentation that we had last week, and it was quite interesting because there it was mentioned that the changes in the Arctic do affect us very strongly. And to focus, for example, in Europe, where I am now, so the warming of the Arctic Ocean can trigger, for example, this is just an example. Obviously, I cannot go into all kinds of examples, but just to focus on this one, that it could trigger, for example, strong cold winters in Europe. So, which could, now I hope Autumn Lim will forgive me if I'm saying something wrong here. I'm obviously not a bird expert at all, but like could, for example, trigger a migration of birds at a maybe different time. And also, now going to the topic of Alex's, for example, that as you mentioned already, Brendan, the vegetation might change. So this would be, for example, my explanation.
All right, I muted myself there. Alexis, thank you, Mariana. I like that you were able to pull back from what we had last week as well. Alexis, how do you see what you study? How do you see vegetation in the Arctic as kind of a crystal ball for what we can expect in the rest of the world?
Yeah, as I mentioned earlier, sort of my focus is the quantitative methods development and thinking about predicting. And so what's nice about being a methods person is that a lot of those methods are really portable. So we can think about sort of these are the ways that things are changing in the Arctic and the high altitudes, and developing those tools and thinking about how are different species controlled by different specific factors is something that's really applicable to sort of the rest of the world. We've used a lot of the same methodologies that I'm using now on the herbarium specimens to look at changes in temperate forests or changes in insect-plant interactions in the tropics. And so I think the nice thing about sort of some of these environmental science topics is that the predictions may not be portable, but the tools are very portable. And as was mentioned earlier, there's a lot of overlap between how these tools are used in the natural sciences and in the social sciences. So thinking about, range suitability is also true for trees, but it's also true for people. So how can we think about what makes ranges and regions suitable for farming, for livelihoods, for living even? And so I think that's sort of the common thread is we can think about predicting all sorts of different variables using a lot of the same methods and tools.
That's really fascinating. I really appreciate that. Autumn Lynn, I want to give you the last word, the last minute. What's your response to that question? It was originally written for you, so I'm interested to hear what you have to say.
I think I'm thinking about that question in two ways. We tend to talk about migratory birds as the bellwethers of change. So they are the signal of change. They are the crystal ball. When they start to disappear, you tend to see larger, more impactful things change in an ecosystem. So on the other hand, migratory animals really serve as a way to connect people across geography, and they are one of our primary tools to be able to help people from other parts of the world appreciate the Arctic because they share those migratory animals. So they can be signals of change, but they can also be signals of connection and understanding. And so from that perspective, I think they're useful from, kind of the negative story, like the birds are disappearing, but they're also useful to communicate the positive connections between the Arctic and the rest of the world. So yeah, that's my closing perspective.
No, that's a brilliant conclusion, actually, because we had talked about that with John earlier, how to tell the story, and maybe we don't have to be the only people telling the story, or maybe we can find other, maybe the animals can talk, maybe they can tell us part of the story, or the vegetation, or the sea ice. I mean, this is really, maybe the environment is telling the story, we just have to listen to it. So I want to thank all of you again. This was an absolutely wonderful experiment. I'm very excited to see what happens for the rest of the Arctic Summer College as well. I want to say one organizational thing before Max screams at me, since we're a little bit over time here, but Diane had asked about the format of presentations and whether this was the preferred or the best or an option, and I want to say yes and yes and yes. The idea was that everybody would work on one research question. How you address that research question, how you tell that story within your group, that's up to you, and it should be based on your skills, your accessibility, and what works best for your members. So if it works best to have 3 different pieces to tie together, that's great. If you can pull everything together for a single presentation, that's great too. The best thing is just to keep us involved, keep us connected, and let us work with you on that process. And that's probably the best way for us to come to, so that everybody's successful in the end. I wish we could all do a round of applause, but I do want to thank you all again. I hope that everybody is a little bit motivated to continue with this process. And next week, of course, we have 2 guest presenters again, and we will switch themes. And what is it next week, Max? We're switching to
Energy and resources.
Energy and resources. So now the people who are appreciative of all of the sea ice being broken up, they'll be next on the docket, and we'll see where this takes us then. have a great week, please. If there's anything that comes up, send me an email, send us an email. And also to our presenters, it would be great if we could post or include your presentations on our website because you are speakers. So if we can, please let us know, and we would appreciate that. Everybody, have a great rest of the day. Have a great evening, and we will see you all next week.